And I hope everyone have their afternoon coffee ready as I am right now. So you might be wondering why I choose that name for my presentation. I wanted to prepare something about A/B testing, and I wanted to express that how frequently we run tests and how frequently we analyze them. So some of you remember the song from which came in 2011, and it was called Every Day I'm Shuffling. So it was a big hit at the time, so it's kind of referring that song. And since A/B testing is a powerful method for you to see what is working well for your products, and for our case, our products are our games, and I'll present an A/B test case study today. So a little bit about me. I am originally from Istanbul, and I live in Helsinki since November 2018. I kind of got used to cold and darkness thanks to all other values of Finland. And I'm currently working as a data analyst at Rovio. I'm in mobile gaming industry for 3 years. I started R-Ladies Istanbul 4 years ago, and it is still growing very well. And in the beginning of 2020, I took over the R-Ladies Helsinki chapter to build a stronger community in here either. And some quick facts about Rovio. If you haven't heard Rovio, you probably heard Angry Birds, but there is more in here. So we are a games first entertainment company, best known for Angry Birds IP. The first Angry Birds game released in 2019, and we evolved from there into customer products, theme parks, movies, and other licensed content. So however, we also have many IP games in different stage of development, even many of them are live globally, such as Sugar Blast and Small Town Murders. And if you haven't played Small Town Murders yet, I highly recommend it. It came out 2 weeks or 3 weeks ago. It's, super fun game. And we have multiple international studios, Puzzle Studio, Battle, and Stockholm and Copenhagen. We are focusing on mobile game genres aimed at different audiences. And in total, our company has 450 employees from 47 different nationalities. And here are some latest numbers. Our games have been downloaded more than 4.5 billion times since 2009, and our Facebook followers exceeded 23 million, and our videos on YouTube has been watched more than 5 billion. So you might imagine that we are working a really big data. And the game I'll talk about today is called Angry Birds Match. So it's a match 3 game where you match some cakes, donuts, etc. To complete goals and pass the levels. And it's released in 2017, and it's a free-to-play game. So we will get back to it in a second. And when we are making games, we aim good retention and conversion numbers in terms of purchases. So the test I'll mention is about increasing retention and conversion numbers. So what is free-to-play? Before I move forward, I want to explain the concept of freemium. So our business model is free-to-play, like many other mobile game companies nowadays. So free-to-play means that the game is available for free, and the players can buy virtual goods with real money if they want. So if they don't want to spend any money, that's fine too. They can keep playing as long as they want, and obviously, depending on the game, they can still have fun. So in our case, the model works like this. So the player tries to match donuts, cakes, to solve the puzzle. If the puzzle is too hard for them, they can use some boosters, and if they need extra moves to complete the puzzle, they can use gems, they are some in-game currency, and they pass levels and collect some other in-game currencies and use those currencies in-game, so players need to get gems, coins, and consume them. That's the basic flow. And there is actually a few different ways to getting the items. So the first is obviously to buy them through in-app purchases. And there are also a few free methods that we integrated into our games, like watching video ads, joining and winning some tournament or in-game events, or inviting their friends on Facebook. So that means that if a player doesn't want to spend anything, they can still enjoy the game. They can even collect items for free. So that's a quick recap for our business model. And so what is game analytics? So it is like game analytics is used for tracking the interactions with players and your game through the entire data supply chain from collection to analysis. So you can have insights about the players, about the way that the players interact with your game, the impetuses on which players make purchases, and the factors that inspire players to abandon your product. So like there are some general questions you might ask, and those questions are leading more and more deep questions when you have data under your hand. But like, why do they love your game? Why do they leave your game? So, or how to keep players engaged, how to serve better game experience. So like, this is a very broad subject, but in general, observing and understanding players via data collection and data analysis is our main goal in a team. So here are some like cute screens from our cute game. Like what kind of things we are measuring. Like there are many items players are collecting and consuming in the game. So for example, our game designers are looking data to understand, like, are we giving too much or too little for free? Or like we have win streaks in the game. If player wins 3 times in a row, how does it affect player? Do they want to keep their win streak and spend more virtual currency in game and win the level, or do they spend actual money not to lose the level? And like many questions you can ask by just looking at the data. And like these are some of the basic data we collect. So besides the basics, such as demographics, device, and date, installation date, so we collect what level and puzzle the player is on, like on the first session duration, how many times they spend on every puzzle, how many minutes they spend on every puzzle, and other information about the game state. So we also collect information about the players' in-game transactions, as you saw in previous slide. So keep that in mind, like we only know how much players spend in our games. Like we don't have their bank account details or anything. So like as we, I don't know, grilled a lot by media who misunderstand what data we have about the players, I just wanted to like point this part explicitly. And this is how the whole thing works. So like player does stuff on the game, and we have events that triggered by those, and the game sends the information about the triggered event along with some user ID through our own API. So on the backend, we log this information to our servers. So we use SQL and run to like run some analysis and share the information in the charts and tables in our dashboards. And what we are using in a company, we are using like Presto databases. We keep our code files on GitHub, and we use like Git for version control, and we use R. Of course, we have some analysts. Analysts are using also Python, like to perform such analysis. And those are the main libraries we used, and we are kind of like a huge fan of Tidyverse. We heavily use dplyr, ggplot2, and Shiny is like another library we used to create dashboards, but not like heavily nowadays. And of course, we document our analysis using R Markdown. And in addition to this, we use R Presto to connect our database. Again, like not very heavily. And sometimes we use Plotly to make interactive plots. So we are coming to the topic slowly. And as I mentioned, I'll share an A/B test case study. And a test is about measuring the impact of having faster or slower move hints in the game. So I don't know if you ever played a match 3 game, you would see that like if you wait a couple of seconds without matching the candies, birds, cakes, or whatever the item is, you see an animation which helps you to see the next matching item. So the thing is that the many games do it differently. Some display the hints immediately, some wait a bit more. So like we wanted to test this, like what is the good amount of time to wait. So we set the hypothesis. So like by showing like faster move suggestions, the core experience will be more fun due to it like guiding the players through the levels faster and reducing the like cognitive load from playing the game. However, because the suggestions are not always optimal, it is expected that the impact will be seen in both engagement and monetization. So like we set 3 groups. Control group will see the hints after 3 seconds. Variant will see it 5 seconds, and variant B will see it in 0.5 seconds. And we decided to run the test only for new players. So to analyze our A/B testing results, we use a method called bootstrapping. A bootstrap sample is a random sample conducted with replacement. What that means is that you can draw the same observation more than once for your bootstrap sample. So bootstrap sampling is like a primary component of random forest algorithm, if you are familiar with machine learning algorithms, and it's quite useful for running simulations. So generally, a bootstrap involves like these following steps. So you have like a sample from the population with a sample size n, uppercase n, and you draw a sample from the original sample data with replacement with the size lowercase n, and replicate it like b times. And each resampled sample is called a bootstrap sample, and there will be totally b bootstrap samples. And then you start evaluate the statistic of theta, or like the estimates of a parameter for each bootstrap sample, and there will be totally b estimates of the estimates of like theta. And you start like construct a sampling distribution with these b bootstrap statistics and use it to make further statistical inference, such as like estimating the standard error of statistic for theta, or obtaining a confidence interval for theta. So like I wanted to show this in 2 parts, and like at the left side, the first 2 parts, load the libraries and call our data files. You can of course call it like directly tidyverse if you want, but I just wanted to explicitly show you which libraries we are using. Like we are calling dplyr, ggplot, etc. And of course, like if you keep your data files in CSV, you need to like load it to R, and then you use like read CSV functions, or if it's on some like Excel file, you can use some read Excel, and whatever is like suiting for your data file type. And on the upper right side, we use like dplyr functions to create some summary tables for our groups. We basically try to look at KPIs of those groups. Also, we like try to prepare our data for bootstrapping, so you can apply the method as many KPIs you need. So yeah, like there are some things that you might want to set before doing the analysis, such as the sample size, and to get the seed like for reproducible results. And like this might be the most technical slide in my presentation, and like here is the part of the implementation of Bootstrap. So like after getting the data ready, what we do is here that like we predefined a metric vector, and it contains our KPIs column names. And first, like we create a vector of metrics to be bootstrapped. For example, we use one function called one-off, and it allows for guessing or subset matching. So let's say I know in general my column names will come from some vector, but I don't know which columns will be present because of like, I don't know, maybe interactivity, reactivity. So like I use like one-off in there. And so the magic like happens in here in the red parts. So you can you can write some settings about for your computational power in here, so or how many samples you want in here, and then oh, by the way, you need to also convert your data frames that you get in here into metrics. So this is the way that the function accepts your accepts the data. So yeah, then you need to run these bootstrapping functions. And then we have the bootstrap statistics. For the variables, we choose. So pure set names also, like we try to extract the statistics matrix. So the rest is just more we want to get the data in a more like tidy format. And of course, like we calculate some summary stats for sample means and look at some lifts. So those code pieces are not representing full process in here, but just to give you a bit idea of how we do it. So we can do it just evaluate the population parameter through an estimator based on an observed sample, and then get an estimate as the evaluation of KPIs. So yeah, what we have now is that like we had the hypothesis, we run the test, and we started to conduct our analysis. But here's a small note. Sometimes people are like quite curious and excited about the tests, and they might ask you to like sneak peek to the results. So this is something you shouldn't do. So people might have some expectations about the outcome, but just like don't assume that you know the expected outcome of a change. So you never know what will be the outcome. So after giving enough time to run your test in production, then you can analyze it. So, and here are some results for the test I mentioned. So there was a decrease in day one retention when comparing with control. And of course, so just as a let's remember that the variant A was a slower variant at like 5 seconds, like you see the hint after 5 seconds. So yeah, it showed some like decrease in day one retention when comparing it with control. And of course, the most part is that the number of purchases decreased. And however, like variant B was the faster variant at 0.5 seconds. You see the hint very like soon, performed better across many KPIs. So while we are looking at the lift at KPIs, like we also look at the confidence. So we want to be able to say that, yes, this is the best option to have in the production. So we often use that kind of visualizations for our reports. So people can see the lift comparing it with control. Also, they can see the absolute numbers in the table on the right corner. And in the end, after doing the analysis, we need to create some reports for our designers, product managers, like to come up like with some decisions. And yeah, so we create some HTML files with R Markdown. Then we share these HTML files into our like game space in the dashboard, so that everyone can reach and read it. How do we create like those files? We use R Studio, and this is our Studio interface. So we create a new HTML document and start writing for each new report. You can keep your code chunks in here so that your colleagues also reach them. And you can write your report in some sections. You can create some charts inside of it. Like it's super handy. If you never used R Markdown, I highly like recommend giving it a try. So okay, we come up with a hypothesis, we run our tests, we evaluated the results and shared it with teammates. So what happens now? Like, should we stop testing and using the best performing variant and never go back, or should we run more tests? So those are the questions like you will need to discuss with your teammates. But of course, for our case, we decided to run more tests with only 2 variants, but I will not cover another A/B test story in here. Thank you for listening, and thank you for R-Ladies Tbilisi for inviting me.